Good morning, guys. All right, guys, here's our last unit for our trigonometry units. So the last topic is called solving trig equations with identities. So at the end of chapter 4, we did we called an intro to trig equations lesson. And so we're just going to be kind of expanding upon that lesson over here. So a bit of review on solving trig equations. So we have these guys we called quadratic trig equations, guys. And guys, if you need to review, I'd go backwards in this unit and maybe kind of review the video on solving trig equations or intro to solving trig equations. It was the fourth video in this playlist over here, and I would definitely go and take it. So guys, it might not be the fourth video, but it's the fourth topic, okay? Because I think there were some topics had 2 videos in them as well. So if you go back like that, maybe you want to review that video as well, and that will definitely help you for this lesson over here. But just reviewing how we solve this one. So this is a quadratic equation, and we're going to solve it by factoring. So hopefully what we recognize is that we have a common factor of cosine x in both terms of this equation. So we're going to factor out a cosine like this, and we're left with 2 cos x plus 1. Sorry guys, I should say when we say solve an equation, it just means it means solve for x and figure out what x is going to be. Okay. So once we solve this, we have cos x times 2 cos x plus 1. This tells us that either cos x equals 0 or 2 cos x plus 1 equals 0. Bit of work over here. I'm going to subtract 1 divided by 2. That means cosine x equals negative 1/2. Okay. Now, our domain is in between 0 and 2 pi. Cosine equals 0 happens at the top and the bottom. So that means x is going to equal pi over 2 and 3 pi over 2. Cos x equals negative 1/2 happens here and here, which is 2 pi over 3 and 4 pi over 3. Okay, and there we have it. Okay, so our solution is going to be x equals pi over 2, 3 pi over 2, 2 pi over 3, and 4 pi over 3. Okay, and this would be the solution for this equation over here. Looking at similar idea for this one over here, we have sine squared minus sine x minus 2 equals 0. And so we're going to solve this guy by factoring. Now, this one over here, it's not a common factor, but we need to factor this one as 2 binomials. So we need to factor this one as 2 sets of brackets, like this. And this is going to factor to sine x minus 2, and then sine x plus 1 equals 0. That means that sine x minus 2 equals 0, or sine x plus 1 equals 0. Add 2 to both sides, that means sine x equals 2, or sine x equals negative 1. Now, for this guy over here, there's no solutions. And the reason is, I'll show you 2 reasons. Guys, from our trig functions unit, we learned that sine x has to be in between negative 1 and positive 1. Okay, here's why it has to be, because if 2 is the same thing as 2 over 1, now if you look at a right triangle and you have some angle theta here, if sine is the opposite of the hypotenuse, what this is saying is the opposite is 2 and the hypotenuse is 1. Now hopefully you'll see that this is an impossible triangle. Like for a right triangle, the longest side must be the hypotenuse. Okay, it just has to be like that. So from here to here must be longer than this guy's over here. So since this is an impossible triangle, we know there's going to be no solutions for this root to the equation over here. Our last one, we have sine x equals negative 1, which happens at the bottom of our circle there, and that means x equals 3 pi over 2 And that is going to be the only solution that we have for this equation here. Okay, we have cos 2x plus 1 minus cos x. So this is going to say the previous two examples, guys, were kind of like review exercises from chapter 4. This is now we're applying what we learned in the trig identities unit to this one over here. So what I'm going to be looking at is this part over here, cos 2x plus 1. Now, looking at I was guys, the cos 2x identities, guys, are always going to be a little bit more difficult because we have 3 options for cos 2x. So we need to be able to recognize which one do we want to use. We want to use the middle one here. And the reason is because I want to make it cos 2x plus 1. And the way we're going to get that is by, if I add 1 to both sides, we get cos 2 alpha plus 1 equals 2 cos squared. So we're going to make this replacement here. Okay, and this gives us 2 cosine squared. Sorry guys, I just totally drew over this here. So this is going to be minus, sorry I couldn't tell there was a minus or plus there a second ago, minus cosine x equals 0. Now, similar to the first example that we did, we have a common factor of cosine x. Factor this out. And that means that cosine x equals 0, or 2 cos x minus 1 equals 0. Add 1, divide by 2. That means cosine x equals 1/2. For this one, we have x equals pi over 2 and 3 pi over 2. Cos equals 1/2 happens here and here, and that's at x equals pi over 3 and 5 pi over 3. So our 4 solutions are going to be so here's our 4 solutions for x over here. All right, guys, hope that makes sense. So again, guys, for something like this, the strategy is we can't do any algebra on this guy as well. So I mean, some people may try to go ahead and factor out, like say an x out of this or something like that, but it's not going to work like that. We need to use a replacement for this using one of our trig identities over here, and then kind of solve it by factoring afterwards. Similar idea for this guy over here. Now we're looking for a solution in degrees instead. Guys, I always think the sine 2x identities are always the easier ones, just because like there's only one option for sine 2x over here. Well, for cosine 2x, there's 3 options here, but for sine 2x, there's only one option. So we have 2 sine x cos x. I'm just using this replacement here. So this is replacing this expression here, plus sine x equals 0. We have a common factor of sine x. Okay, so once we factor this one out, that means sine x equals 0, or 2 cos x plus 1 equals 0. And that means that cos x equals negative 1/2. Sine equals 0 happens here and here. So we're going to say x equals 0 degrees, 180 degrees, and 360. So in this case, we're including 0 and we're including 360 in this domain over here. Cos equals negative 1/2 happens here and here. And that is at x equals 120 degrees and 240 degrees. So just going to group all of our solutions together here. And that's our solution right there. Okay, so guys, these questions over here. These definitely do pop up on your unit finals and your quizzes like that. You'll see, guys. So we need to recognize that, okay, we have a sine 2x or a cos 2x. We need to replace those expressions with one of the identities that we have on from our formula sheet. Okay, so guys, make sure you have your formula sheet next to you when you're doing this work over here, guys. It's definitely necessary for these works over here. Okay, solve each trig equation. So what we're going to do over here is I want to figure out a way. This question is a little different. So first of all, we have coses and sines. Okay, so it's kind of different. We can't really solve this one by factoring because this is sine and this is cos. What I'm going to do is I'm going to work to replace this guy over here. Now our Pythagorean identity is sine squared x plus cos squared x equals 1. So if I subtract sine squared from both sides, we get this identity over here. So I'm going to make this replacement where cos squared x comes in to here. Okay. So from here we get 2 cos x plus cos squared equals 3. I'm just going to go minus 3 minus 3, and now we have cos squared x plus 2 cos x minus 3 equals 0. So we're able to, so now we have one equation that just has cosines in it, and now we're just going to solve this guy by factoring. This is cos x plus 3 times cos x minus 1, okay, which means that cosine x plus 3 equals 0, or cosine x minus 1 equals 0. This means that cos x equals negative 3, which there's no solution. So guys, we reviewed this earlier on with the sine example, but cos and sine have to be in between negative 1 and positive 1. So it's not, there's no solution over here. This means cos x equals 1, which happens here. Therefore, x equals 0. And in this case, we're going to include 2 pi as well. So the domain was giving us, that means we're including 0 and we're including 2 pi for our domain. So we're going to include both of these solutions as well. Okay. Guys, there's a typo here. This should not be a y, this should be a 1. So please make that edit. And for this one over here, it's asking us to give a general solution in radians. So what we have to do for this question over here is recognize that cosecant x is 1 over sine x. So we're making this substitution here, which gives us 2 sine x equals 1 minus 3 over sine x. I'm just going 3 times 1 over sine x, the same thing as 3 over sine x. Okay. Next step we're going to do here is we have a sine x in the bottom of the fraction. So I'm going to multiply the entire equation by sine x over 1. So that means this has to be multiplied to this term, and to this term over here. Same thing as multiplying both sides of the equation by sine x. That gives me 2 sine squared x equals sine x minus 3. Okay, so now we're just going to set one side equal to 0. And we're going to solve this by factoring. Guys, there's supposed to be another typo, my mistake. This should have been a plus 3 cosecant x over here. And that means this is going to be a minus 3. And now I think this will work. So this is going to be a plus 1 minus 3. And this will factor properly now. Sorry guys, like that. So this makes sense now. So for the first one, we have 2 sine x minus 3 equals 0. Add 3, divide by 2. Sine x equals 3 over 2. Now this is outside of our domain from -1 to +1, so therefore there's going to be no solutions for this root over here. And we have sine x, or sine x plus 1 equals 0, and that means sine x equals -1. And that is happening at the bottom of our circle here, which is at 3 pi over 2. That means x equals 3 pi over 2. And we want a general solution in radians, and so this is our only solution. So we're just going to go put plus 2 pi n. And this will account for all the surfaces. So we're going to hit 3 pi over 2, add 2 pi again, we'll hit it again. And we'll keep hitting this solution every time we add 2 pi to this solution over here. So that's going to be our general solution for this one. And we are finished. Okay, we have sine 2x equals root 2 cos x, and we want to give a general solution in degrees. So guys, hopefully recognizing we have a sine 2x. We want to be able to use this identity over here. Okay, we're going to set one side equal to 0. So we have 2 sine x cos x minus square root of 2 cos x equals 0. And we have a common factor of cosine x. So this is going to give us cos x equals 0. Or 2 sine x minus root 2 equals 0. So this means that sine x, if we add root 2 and then divide by 2, equals root 2 over 2. Unit circle time. Cos equals 0 here and here. Sine equals root 2 over 2 here and here. Okay, so we're going to have, for these two solutions over here, I'm just going to say x equals, so we want a general solution in degrees, so this is 90 and this is 270. That means we have 90 degrees plus 180 degrees n, where n is an integer. And then we're going to do each of these solutions here individually. So I can call this one x1. x2 is going to be 45 degrees. 45 degrees plus 360n. And then x3 is 135 degrees plus 360 degrees n. And these three parts together, like this, is going to be our solution to this equation over here. Okay, so we have cos 2x plus cos x equals 0, and give a general solution in degrees for this one. So again, guys, a little bit trickier for cos 2x because we need to decide which one are we going to use. Now, a strategy here is we want to choose the one, like if I choose this one, it's not going to work because there's going to be a cos squared and a sine squared and a cos x in there. So we have two different types of ratios over there. Same thing with this one. If I go cos 2x is 1 minus 2 sine squared, that means I have a sine squared and a cos x in the equation. So I'm going to want to use the middle one over here. And we're going to use this replacement here. So this gives us 2 cos squared x minus 1 plus cosine of x equals 0. I'm just going to rewrite this one right here because I think it's easier to factor this way. I want to be able to factor this expression here. So we have 2 cos minus 1 times cosine plus 1, and that means that 2 cos x minus 1 equals 0, or cos x plus 1 equals 0. This is going to tell us that cos x equals 1 over 2, and that cos x equals negative 1. So guys, we did a few of these examples in chapter 4. The general solution went like this. Cos equals negative 1 happens here at 180 degrees. Cos equals 1/2 happens at 60 and at 300. So the simplest general solution we can give this one, if you say we have 60, well, hopefully we see that these 3 angles here are all 120 degrees apart. So if I go 60 plus 120, I get 180. Plus 120, I get 300. If I go plus 120 again, I would get 420, which is a coterminal angle to 60, and keep adding 120 like this. So our general solution is going to be x equals 60 degrees So it would be 60 plus 120n, where n is an integer like this. Guys, I know trig is such a long unit in grade 12 math right now. So guys, so congratulations for finishing it. In my opinion, I think Math 30 trig is the hardest unit in all of high school math, period. I think it's harder than anything we do in calculus as well. It's a very difficult unit, guys. So I'm proud of you guys for finishing it. Good job. Just kind of keep up with your studying, guys, and hope that your unit final and your quizzes go well. And as always, guys, please send me a message if you have any questions, and I'll see you guys in the next unit.